Hello again. We are going to see in this third module the first circuit you are going to build with Simulink. First circuit will be a frequency and time analysis using the RTL SDR dongle. The first thing is to install, of course, the RTL SDR dongle in MATLAB, and then we will make a frequency analysis using a spectrum analyzer block. Then this block, we have to configure the spectrum analyzer. You have to remember that the frequency range of the RTL goes from 24 to 12,766 MHz, and it has a gain control of 0 to 50 dBs. Maximum sampling frequency is 3 megasamples per second. Then, after doing the spectrum analyzer, we will make a time analysis using timescope. And here we can see the IQ signals on real time. This is the complete Simulink block. We have the RTL SDR block in the middle. We have a input constant for the frequency and another constant for the gain, and two blocks, the spectrum analyzer and the timescope. We are going to build these blocks, and we will see results like this. This frequency spectrum of the FN analog band in 98 MHz, and these are the time IQ signals. Let's do it with the RTL SDR dongle. We open MATLAB, Simulink, and then we open a new Simulink model. Here we have the model, and we build the different blocks. The blocks are on this part, library browser, and here we have the first, the RTL SDR radio. We put this block here, okay? And well, the best is to have two screens, and we pick and place blocks from one side to the other. Now we go to the spectrum. We can search block, this block, spectrum. We take the spectrum block. It's here, a spectrum analyzer, and we take the time scope from the blocks. Here is important to take time scope, not scope. It's a different graphical representation. So we have these blocks, and we can connect directly to the RTL very easily. Now we open the RTL device, and we configure the different parameters. We are going to select one input port for the frequency. We configure another input port for the gain, and the rest of the parameters we define a sampling frequency of 1 megahertz, and we can see if it is working correctly. We have to check apply first and then initialize, and we can see that it has been initialized, and these are the parameters of the RTL dongle. Now we have to put two blocks of constant to input the parameters, one for the frequency and another one for the gain. This parameter will be, for example, 98.7 megahertz, which is a radio FM radio frequency signal. We made it bigger to see the parameters, and then we put again, the gain goes from 0 to 50, so we can put 30 which is medium gain, and we can change this parameter to have it more clearly. So now we have all the blocks in the RTL, so we can execute. We put here is the simulation time. We put 20 seconds, which is enough to see a complete simulation, and we can execute and see the results. This is the execution key, and here we have the time scope and the frequency spectrum of the system. We are going to prepare the environment to be able to modify the different parameters. And you can see that we can change the different parameters. First, we stop the simulation and we are going to change the frequency and time response. We go to configuration properties and we change the time to see the signal on a shorter time. Now time span is automatic. We put user defined, and for example these are low frequency signals. We put here a time of 0.1 seconds. And now we can execute and see the results on real time. Take some short time at the beginning. You can see here, we can see the graph, and we can make it bigger. With the zoom signal. Here there are two signals, the I and Q signals. So we have the I in yellow and the Q in blue. And here is the spectrum. We have the spectrum of our FM modulated signal on this point. We can change the frequency to select this spectrum. For example, this can be done in real time, although it's better to do it with the simulation stop it. 98.5. You can see how it has changed. And we can change the gain, more attenuation, 0 dB gain. We can't see the signal. Or we can put 40, and then we can see more powerful signal. Here there is an auto scale, and we can see the time. And also, if the graph is not clear enough, we can see it more inside. This part works like a oscilloscope, so we can change the parameter and see the behavior. There are some delays when we change the parameters. You can see the graph here. So this is a frequency spectrum and time spectrum. There are also some tools here to see different parameters. Where we can measure. We have some markers, marker 1 and markers 2. We can measure the frequency different, and we can have more measurements on this part. And also on the time, we can have also some delta markers to measure different aspects of the signal. So these are the first simulation, frequency and time, using the LTE dongle. You can see as it can be done very fast and very easily. Thank you for your attention.